Hello, so let us look at number 2 from year 2010, Form A. Alright, so let's get started with the first question, number 2. So I'm going to just give you a little bit of time for you to read the question, and then we'll talk about them together. Alright, so this is the chart that's given. T is the hour, and E talks about hundreds of entries, where T goes from 0 through 8. Now, once again, the values of E is given right over here. Now first, use the data in the table to approximate the rate. Now when we are given the values, in order for you to find the rate, all we have to do is find the slope about that point, just like mean value theorem. So A. When t equals 6, then it has to be between these two. So what we like to do is this. E prime of 6 can be approximated by, just like using the mean value theorem, E of 7 minus E of 5 over 7 minus 5. Now basically this becomes 21 minus 13 over 2. Now the numerator in this case becomes 8, so we end up getting 4. So basically in this case, because 400, the question is in approximate the data, the rate of the data in which the entries were being deposited is simply 4. And since they told us the unit, which is in hundreds of entries per hour, so it will be 4 will be our answer. Okay, let's look at part B. In this case, we're using the trapezoidal sum, and then we want to approximate this value. So in fact, we can calculate 0 through 8 of E of t dt using the trapezoidal sum. We'll try to calculate this one first, and then we'll apply 1 over 8 after that. First trapezoid can be between these two. So the height being 2, then first base and second base will be these two values. So what we end up getting is this. 2 times 0 plus 4 whole thing divided by 2. That's the first trapezoid. Second one, in this case height is equal to 3, so 3, and then 4 plus 13 over 2. Third trapezoid is between these two, so which is 2, and then 13 plus 21 over 2. The last one is here, 1 times 23 plus 21 over 2. That's what we end up getting. So our first value here becomes simply 4. Second value here, we're going to try to calculate this one. How about this? Let me just put everything into the calculator. How about that? So first value we know that was equal to 4. Second one is 1.5, because 3 over 2 times 17, plus third one is simply 34, because 2 and 2 cancels out, we have 34. And then the last one is 21 plus 23 divided by 2 becomes 22. Then we get 85.5. So $85.5. Then this expression, 1 over 8, 0 through 8 of E of t dt would have then equal to 85.5 divided by 8. Then we get 10.69. So 10.69. Then in this case, since the expression that we are looking at is the average value formula, so this basically tells you that this is average this is entries. So using the correct unit, since this is in hundreds, so our correct response will be 69 entries. Entries, right? That's basically what we end up getting. And then this basically expresses the average number of entries in the box. All right, over that 0 through 8 hours. Let's look at part C here. At 8 p.m., volunteers begin to process the entries. All right, they process the entries at the rate in this given model. So basically what I like to do is maybe I like to put this one into the calculator first. So we have x cubed first minus 30 x squared plus 298 x minus 976. Now, and we want to calculate how much has been calculated at this point or processed. That means we're gonna, and then our window has to be a list containing 8 through 12. So let's put the window as maybe 7 through 13. And we're gonna go for zoom fit. That's basically what we end up getting. So what we like to do is this. We like to second trace calculate, and number 7 once again. Lower limit was equal to 8. Upper limit was equal to 12. Then we end up getting 16, as you can see here. So part C, amount of entries that has been processed is simply P of t dt from 8 through 12, which we calculated to be 16. That means amount not processed is simply we had up to 23, so 23 minus 16, which will be equal to simply 7. This implies 700 entries has to be processed. Have to be processed. All right, let's go for part D. According to the model from part C that's given here, at what time will the entries being processed most quickly? Now, most quickly, in this case, we're talking about the highest value. Now, then when do we have the highest value? As you can see, this was the graph. That means we are looking at, this seems to be the highest value because that's the relative maximum, or we also have to check up on the endpoints. So let us try to look into those three values. So this is t, and this is p, how much it was processed, rate which was processed. So we can calculate 0 and then our endpoints quite easily, or 8 and then 12, and then we would like to figure that point out also. So second, calculate the value, which was, let us say when x equals 8, what do we get? It was equal to 0. So that was rather simple. 0. How about when x equals 12? It was equal to 8. Now, how about the highest point over there? In order for us to calculate it, we're going to go for the maximum, number 4. Left bound, we're just going to call it as 8. We know that they will definitely do it because that's left of the value. The right bound, why don't we just go for about 10? Okay, let's look at it one more time. Second calc, maximum number 4. Yes, I pressed the wrong button. Left bound was 8. Right bound was 10. And guess, yes. Maximum was 9.81. So as you can see, 9.18, my bad. And then it was about 5.1. So highest rate was when t was equal to 12. Justify your answer by this way. When t was equal to 12. All right, that's it. I'll see you guys later. Bye-bye.